Thank you for the introduction. The key message of my talk is that information alone is not enough, plus we need shared experiences to transform it into actionable knowledge. As a data scientist, I revel in crafting stories from numbers. I delve into various scientific fields to understand how data is generated, distorted, and interconnected, much like a composer crafting a symphony. I want to share my perspective on the landscape we're navigating. But first, let's start with the region I hail from, European Union, Slovakia, a small EU country with about 5 million people in a relatively small area. How does New Zealand compare? In a true map comparison, considering its position relative to the equator, New Zealand stretches from the middle of Austria to the tip of Tunisia in Africa. To be precise, we should flip the map of New Zealand, with the North Island pointing towards the equator, which, in this perspective, is at the bottom. New Zealand's area is slightly larger than Romania, with fewer inhabitants than Slovakia. It also has surprisingly less forested land dedicated to carbon capture. Despite being a rainy country with ample precipitation, it surpasses the European Union average. Now, few key indicators from the climate change New Zealand perspective. Its emissions profiles. Agriculture accounts for over 50% of its GHG emissions, which is unusual in the EU. The power industry ranks 6th in emissions, thanks to the country's heavy reliance on hydro and geothermal energy, resulting in lower CO2e per kilowatt-hour emissions than common battery energy storage systems. I could very well portray the anthropogenic impact of New Zealand. But today is not the time for that. It is important that I provide the data for this evaluation from direct sources and not from data aggregators. The country's surface is warming at a rate far exceeding even the most pessimistic IPCC scenarios, which is alarming. This illustrates that low emissions from one country can't counterbalance the lack of commitment to emission reduction in others. This also confirms the rule that climate adaptation is a much more important element than mitigation itself. New Zealand needs more sustainable nature-based carbon capture storages, aka greenery. What kind of green? If we think in the context of the previous information, it is mainly about trees. Zealand is a really green country, but thanks to the pastures. So, Zealand needs to plant trees. What kind? This is answered by a study by the Crown Research Institute from 2020, which, among other things, addressed the sequestration performance of various types of vegetation during their life cycle. And it was redwood that came out as the winner. Precisely thanks to the ability to capture carbon linearly from age 10 during the life cycle. In the following graph, you can see the great potential for planting such trees. We know more or less everything. The question is, who will pay for it? Increase taxes on the population? Is there really no money for that? Let's look at it from a different perspective. According to the Advertising Standards Authority of New Zealand, an organization that annually prepares a report on New Zealand advertising turnover, more than 30 billion New Zealand dollars have been spent in this country over the past 11 years. Thus, a 10% share of this value is $0.3 billion. This would be enough to plant 124 million 2-year-old redwood tree seedlings, occupying 3,000 square kilometers when mature. This is only 1% of New Zealand's land area, but it will create leverage to reduce up to 3% of New Zealand's GHG emissions. I'll repeat that 10 times in a row. And we have a huge potential to reduce this country's emissions while preserving the country's industry, agriculture, and economy. How many other similar sources can we find in this country? Is it really impossible? We have to start wanting it. This is how we work at our International Climate Adaptation Research Institute, where I proudly serve as Vice President. What do we focus on? Our main areas of expertise include green and blue infrastructure, grey infrastructure, biodiversity, buildings and surroundings, building energy efficiency, impacts, adaptation planning, ESG/CSR, emissions, and more. Let me illustrate it with some examples. We create, measure, use, and share large data and thinking instead of relying on feelings. We generate ideas and help boost businesses through our work because activism alone is not enough. We understand the significance of global warming and strive to highlight this phenomenon further. We prefer to discuss local warming. It's more practical to use local data than global constants. We use modeling of rainwater retention, including complex scenarios involving drought periods, evapotranspiration, and more. We logically connect renewables and green and blue infrastructure into symbiotic systems that mutually influence each other. We conduct geospatial analyses to understand the potential of building roofs and their surroundings, and we are currently working on a Horizon project with Trinity College Dublin. We've developed unique methods for measuring air quality and microclimates, attracting interest from developers and municipalities alike. I could go on, but this introduction suffices for now. My work with data has taught me that we have an overwhelming amount of it. The problem is the kind we have. It is all about data. However, we arrive at a condition I call a global illness growing core, better, overflowing emptiness of data. We have so much data that it slips through our fingers right into the drain. Many of these data points haven't helped us much, if anything, they've caused harm, especially when considering the data spread via social networks. The question then becomes, which data is correct, and for whom? For whom? The audience of this Congress includes diverse roles, such as architects, urban planners, and many others. Imagine each of you is someone searching the internet for information on projects, construction, or research related to green infrastructure or blue, or both combined with renewables. Most of you will likely open your preferred browser, use the default search engine, or visit a thematic portal, a scientific journal, a social network, or even popular AI tools. Anything goes. I initially wanted to conduct an experiment with you here, but it would take too much time. So, I experimented at home. The goal was to test internet search engines with a complex prompt, as shown on the screen. Some numbers. This prompt contains 737 characters and 110 words. This is the first problem of the results because Google only processes the first 32 words, ignoring the rest of the prompt. Google returned between 0 and 24 links during repeated attempts. Microsoft Bing fared slightly better, allowing up to 2,000 characters and returning between 3 and 3 million links during repeated attempts. What did I find? A plethora of irrelevant information, with very little of what I was searching for, wasting a lot of time. This method of searching has low to zero reliability. How can we improve it? We could leverage AI and LLM's vast search performance. After all, it's AI. ChatGPT-4's match ratio in the retrieved information wouldn't please even an average reader. It only matched 7% of the searched conditions. 13% of the conditions were only partially addressed, while 80% were completely discarded. Why is that? Because LLMs can produce incomplete or misleading responses if relevant information isn't present in their training data. Such structured data is not found on the internet, it simply doesn't exist, or if it does, it is in negligible numbers on mini-portals covering a limited area and time. What is the cause? Welcome to the post-factual data mess era. Over the past 23.5 years, humanity has created about 80 zettabytes of data, an unimaginably large number. More significantly, half of this data was generated in the last 2 years. As you can see, many well-known content providers are included. Similar trends are occurring in scientific journals or blogging platforms. Considering that most of the content on the internet isn't created by the brightest minds, the quality of what you find will reflect that. Therefore, searching for detailed information on green, blue, and grey infrastructure is extremely challenging. We're changing that. Transforming content into something useful. Making it accessible. Maintaining it. To achieve this, we need a platform, an Open Data Catalogue, that can gather and receive information and evaluate it. For such a platform to succeed, it must be open to everyone. This data should not only be textual, descriptive, and visual, what we call static data, but should also include perspectives through 3D data, LiDAR, and satellite imagery, complemented by a comprehensive set of nature performance indicators measurement information. Imagine that a complex prompt like the one in our initial experiment could be processed in seconds, with highly accurate results. You could adjust the weight of what you're searching for. Some aspects might be more important than others for your search. All this right on your phone, tablet, or laptop. Imagine you are one of the many searching for information about green infrastructure, blue, and so on. You ask the system to find it for you, and you get to play with the search parameters. You get to control the search, not the system. We are preparing this system. We're in the preparation phase, securing funds to complete the methodology. In 2026, we will build and launch it. Consider this a call for collaboration with investors, content providers, and partner organizations. It is a call from our institute and WGIN, with whom we collaborate closely on this project. Why Open Data Portal? Why dynamic data? Because the only source of knowledge is experience. Share it. Thank you very much, and I'm glad you didn't fall asleep during my lecture.